through photophosphorylation. We talked about P680 and P700. And resonance induction. Electron excitation. Electrons boosted to an excited state, falling to ground state, causing electrons in neighboring molecules, and therefore it had to develop from the perimeter to the special pair. We gave details. I gave details about certain aspects of photophosphorylation, the Z molecule, the manganese-containing molecule, the pumping of magnesium across the membrane, and the problem of developing a high voltage that the magnesium solved, and the high pH, high pH in the stroma, low pH in the thylakoid lumen. The full structure, the chloroplast has a lot more labeling to do than the mitochondria. You don't have to know my neighborhood in Fresno, except where the Fasano twins live. Phaeophytin A, plastoquinone A. This, by the way, is plastoquinone B. The one that's mobile in the membrane. Similar in function and in structure to ubiquinone.
Can you talk about what the dark reaction is in this number?
There's no such thing as a dark reaction.
As the Calvin cycle?
Thank you.
Why it shouldn't be called the dark reaction?
Because of the reasons that I gave for regulation of the enzymes.
Okay.
Okay. So Rubisco has to have carbon dioxide added to it by Rubisco activase. That happens only at alkaline pH. That happens in the stroma. To make alkaline pH, you pump protons into the thylakoid lumen. That happens in the light. And once the carbon dioxide is added to the Rubisco, you need a cofactor, magnesium. Magnesium is pumped out of the thylakoid lumen during photophosphorylation. That happens in the light. Certain enzymes of all of the phosphatases and the kinases, if you number all the reactions, 3, 6, 9, and 13, require disulfide bridge reduction by thioredoxin. Thioredoxin gets its hydrogens from ferredoxin. It can only get hydrogens from ferredoxin if photophosphorylation is occurring, happens in the light. A number of enzymes of the CBB are rely on alkaline conditions, just general pH, their pH maxima or their pH optima are alkaline somewhere around 8.3 or so. And then finally, a big issue, like the activation of rubisco, is the activation of ribulose kinase, which makes ribulose 5-phosphate into ribulose 1,5-bisphosphate, and that's allosterically regulated by 3-PGA, and 3-PGA will either have 2 or 3 negative charges based on pH, and where it's got 3 negative charges that it would have under alkaline conditions, it's a strong allosteric activator of ribulose kinase, and where it's got 2 negative charges, it's a strong allosteric inhibitor of that enzyme. And so alkaline conditions happen in the stroma when photosynthesis, photophosphorylation is occurring. I don't put an arrow where the carbon dioxide binds because it's too complex. It's actually going to bind to that carbon right there. But look it up in Leninger and you can see that it's like a 9-step process where this becomes a double bond and that becomes a hydroxyl group, etc.